Let's go ahead and look at the Hindu-Arabic numeration system. We'll be taking notes on our composition notebook. Feel free to pause anytime that you need to stop and take some more time to copy down your notes. Okay, so we're going to title this the Hindu-Arabic numeration system. Some of the vocabulary terms we're going to be looking at, we're going to define numeration system. We're going to look at numeral, number, and digit and tell the difference between those terms. We're going to look at decimal place value system and the base 10 number system and define those. We're going to define place value, and we're going to talk about the key properties of the Hindu-Arabic numeration system. Okay, so let's begin with numeration system. A numeration system is a system that is a collection of symbols to represent numbers. So symbols and numerals with definite properties. For example, can you add? Can you subtract? So the different properties in our systems. Remember, the ancient civilizations have all had their different types of numeration systems, from the Mayans to the Hindus. Remember the Roman numerals? That's an ancient civilization that we still use those symbols today. So I'm going to put here, it is a system that includes symbols and properties. So again, some ancient civilization would be the Mayans, the Romans, Roman numerals, and the one that we're using today is the Hindu-Arabic numeration system. Hindu-Arabic numeration system. Okay, so let's look at these three terms: numeral, number, and digit. Now these terms are not used very often. You never hear people saying, oh, the numeral. We always use the term number for everything, but it is incorrectly used. So let's look at the difference. So let's begin with numeral. So a numeral is a symbol such as a word or a figure to represent a number. Okay, so let's do that better. It is a symbol such as a word or figure. It is a symbol such as a word or figure. For example, the word F-I-V-E. This word represents a number, right? But when I write it like this, I'm referring to the numeral. If I actually draw out the symbol here, I am referring to the numeral. So this is the numeral 5. This word represents the numeral 5. A number, however, is referring to the quantity. It refers to how many. How many, or the quantity. For example, I have 5 apples. So in this example, when I'm referring to 5 apples, I'm actually counting them. So when you're counting, you're looking at the number. When you're just referring to the word or to the symbol and you're writing the symbol out, maybe you're teaching them in pre-K how to write the symbol or in first grade, then you're referring to numerals. Okay. Every numeral is composed of digits. So 0 to 9 are called digits. Okay, and they are used to make numbers. So every number that we have is composed of these digits arranged in different formats, right? Like 21, 1, 2, 12, and so on. So all our numbers are composed of these 10 digits. Let's write that down. 10 digits. So remember, we're counting the 0. So it is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So that makes a total of 10. Okay, so the Hindu-Arabic numeration system is also called the decimal system or the base 10 system. And so we're going to look at these two terms. Okay, let's go ahead and write this sentence. Our decimal number system is a base 10 system. So notice how they're using the vocabulary here. Our decimal number system is a base 10 system. Our decimal number system is a base 10 system. Okay, so what does base 10 mean? So base 10 means that we group our objects into groups of 10. So this is groups of 10. Our base 10 system is based off of groups of 10. So if you see the place value chart that I included here, I went ahead and put the exponents to show you the base 10. So we've got ones, tens, hundreds, thousands, but notice that every one of those values can be written as an exponent with base 10. So it was a reminder, for example, that 10 to the 0 power, which is my ones, 10 to the first power, which is my tens, 10 to the second power is my hundreds. Okay, so you see how all of our values, our place values, have a 10, base 10. Another way of looking at this is that, remember, we're talking about bundles or groups of 10. We know that 10 ones make 110, right? So you get 10 pennies and you turn it in for a dime. You have 10 $1 bills and they give you a $10 bill. So we're looking at every 10 ones make 110, and we know that 10 tens equals to 100, and so on. So these are my groups. Okay, and that's what we're talking about in base 10, that everything is based on groups of 10. Ones, tens, hundreds, and so on. Okay, so let's look at the key features of our Hindu-Arabic numeration system. So key features of the Hindu-Arabic system. Got to be a shortcut for this, right? Okay, so let's start with 1. Our system has 10 digits. Remember, we referred the digits 0 through 9. Our digit relies on place value. Where the digit is determines its value. For example, ones, tens, hundreds. So we use place value to determine the value of a digit. Our system has a base 10 system, which means we group in groups of 10. Groups of 10. Our system uses 0 as a placeholder. We need the 0. And then the last one, and I'll explain in a little bit, that determine the value of a number, we can use expanded form in which we add and subtract, add and multiply. So the additive and multiplicative property here. And we use expanded form in order to determine the value. So let's work to determine the value of a numeral. Okay, so we have our key features. Our system uses 10 digits from 0 through 9. We rely on place value to determine the value of the digit, where that digit is placed. Is it a ones? Is it a tens? Is it a hundreds? Our base 10 system is groups of 10. We use a 0 as a placeholder. And we're going to use expanded notation, which uses addition and multiplication to determine the value of a numeral. So we'll look at some examples in a minute. Okay, so we said first of all, we have 10 digits. We already have that here in our previous page, but if you wanted to write it again, so our 10 digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And all our numbers are composed of these digits. We use place value. So the position of a digit determines its value. The position of a digit determines its value. So let's use a place value chart to help you understand this definition of place value. So look at the number 111,111, and you'll notice that every digit is a different value. They're not all ones. Their face value is 1, but where they're located determines its value. So if I have 111,111, the first one in my ones column, in my place value chart, this is a 1. If I'm referring to this one right here, it is a 10 because it is in the tens place. This one right here represents a 100 and so on. Ones, tens, hundreds, thousands, and so on. So how do I know the difference between these digits? It depends on its position. Where is it located? Is it ones? Is it hundreds? Is it thousands? And so on. Okay, so let's look at this question. Is 43 the same as 34? No. But how do we go about explaining that? So let's look at this question here. And we know no. And we know that. So let's go ahead and decompose. Now the term decompose means to break apart. So when I look at the 43, I see a 40 and a 3. So notice how the 4 is really a 40. If I decompose the 34, I see a 30 plus a 4. So you can see they have different values. Look at this 4 represents a 40, while this 4 represents 4 ones. So they are not the same. What's the difference between this 4 and this 4? Well, again, this 4 is a 40, and this 4 is 4 ones. So this is 4 tens, and this is 4 ones. How did I know that? Because it's position. This is my ones place. This is my tens place, my hundreds place, and so on. Ones, tens, hundreds, and so on. The 4s have the same face value, but different place values. Okay, so the next property that we were looking at, our next key feature, was the base 10 system. So our numeration system uses the base 10 system, which we said it groups our objects into groups of 10. A grouping system based on groups of 10. And we said, for example, that 10 ones make 1 10. 10 tens make 100, and so on. Okay. Another important thing about our base 10 system is that each place value is 10 times the value of the place to the right. So let's go ahead and write that sentence down here. So the second thing is that each place value is 10 times the value of the place to the right. We'll look at an example. So in our base 10 system, we use groups of 10, and that every place is 10 times the value to the right. Let's look at an example here. As you move to the left, each place value is 10 times larger than the previous one. Okay, so I'm just going to quickly do a couple of columns here. So here I have my ones, tens, hundreds, and that's enough. So as I move to the left, I am multiplying by 10. As I move to the left, I am multiplying by 10. So 100 is bigger than tens. It's 10 times bigger because 10 times 10 is 100. 10 times 10 is 100. Let's look at our ones. The tens is larger than my ones. If I multiply 1 times 10, I get 10. 10 times 10, I get 100. 100 times 10, and so on. Okay. Let's look at the decimal number system. So we've been talking about our place value chart, but I wanted to show you the overall picture here of our decimal number system. So we have a place value chart, and you will be asked to go ahead and create a place value chart. It's in the next assignment. And so here I went ahead and printed the one that was in the assignment. You can always just draw your own. Now this one I colored the whole thing, and I realized it was so much. You can just color less with your color pencil. Here we go. This one has a little bit less. I went ahead and did the decimals on the right of the decimal point, and my whole numbers are to the left of my decimal points. And I did every period, every 3 numbers is a period. I did each one a different color. So this is my ones period, my thousands period, and the millions period. Up here on the top, you see that I included my exponents, 10 to the, now notice here I have a 1. I didn't put 10 to the 0 power. That is optional because in the lower grades, they don't teach 10 to the 0 power till they get to probably pre-algebra. So we could either have a 1 or we could have 10 to the 0 power. So you can go ahead and include that. Then we have 10 to the first power, 10 to the second power, 10 to the third power, and so on. Let's look at our decimals. In our decimals, we have a negative. 10 to the negative first power, 10 to the negative second. So we use the negative exponents to represent the decimals. The decimals are my tenths. Notice it has a TH, tenths, hundreds, thousands. So we're going to use this place value chart in other exercises in which we read and write whole numbers and decimals. Once I finish this, I'm going to crease it along where it says decimals. I'll just fold it where it says decimal. Not really the center, but it's a good place to divide it up. And I'm going to glue it along my gutter of my notebook. So here's my place value chart. I'm going to run some glue down this, and I chose to fold it where it says decimal. You can fold it anywhere. And this way I have my whole numbers greater than 0 on my left and my decimals to the right. Okay. And we'll use this later. So here is the whole decimal number system place value chart. Okay, we said periods are every 3 numbers. So notice you have 1, 2, 3. This is where you would put your comma. 1, 2, 3, comma. So here would be my commas. And normally we use that for our whole numbers, not in our decimals. So on the left side of the decimal point, we have our periods. So let's write that term down. Now notice that the first one is my ones period. In some textbook, it's also called the units. Then notice it switches over to the thousands. There's no hundreds. It goes from the ones or the units to the thousands to the millions and so on. Okay. So let's go back to our key features here. We already had number 3, which is the base 10 system, which is our groups of 10. Let's go to number 4. Another key feature is the use of 0 as a placeholder. And if you look at the place value chart, if we have 6,800, I need those zeros. I need the zeros, otherwise it's just a 68. And so the zeros are taking up that spot so that I could scoot this over, and this would become my ones, tens, no ones, no tens, hundreds, thousands. I noticed that in the elementary grades, sometimes what they'll do for place value, have you ever seen where they do this? And they put ones, tens, hundreds, thousands. Maybe we could put TH for thousands. And so sometimes when they're working with the students, they'll draw a quick little symbol across the top to indicate the place value. O for ones, T for tens, hundreds, thousands, and so on. So 0 is a placeholder. Okay, so let's look at the last key feature, which allows every number to be written in expanded form using addition and multiplication. But the terms in the book use the words additive and multiplicative. We'll explain that. Okay, so determine the value of a number. We're going to use the value of a numeral. There we go. We're going to use expanded form. So in this example, we have 6,703. Now notice how I did not use the word and. 6,703. Now, if I wanted to go to my place value chart right here, I can set it up. Here's my decimal. So this would be 3076. So I can use my place value to help me read and write my numbers. So 6,000, there's my comma. I read the period is, right, the comma is the word thousand, so 6,703. In order to write it to expanded value, I simply look up. So it's 6,700, no tens, 3 ones. So this is going to become 6,700 plus 0 plus 3. And it's a good idea to include the 0. Okay. Let's continue to the second form of expanded form, in which we go ahead and say, okay, here I have 6,000s. I have 700s. We have no tens. And we have 3 ones. So I have 6,000s, 700s, 0 tens, and 3 ones. Only notice how we're writing it with a multiplication. So this is the additive form, and this is the multiplicative form of expanded form. Let's write that down. We didn't write it. Expanded form. So this helps us to determine the value of each digit that makes up that numeral. Okay, so those are the 5 properties. We can go back and highlight them to make sure that we have them all. So this was number 5, which was additive and multiplicative. Here's my number 3. Maybe we would highlight these to make sure they stand out. 0 as a placeholder. Expanded form using the additive, which is additive and multiplicative. Then in our previous page, we had the use of 10 digits, place value. So 1, 2, right? 1, 2, 3. I write real big, so you probably wrote smaller. That's okay. Up to number 5. There we go. So the 5 properties, 5 key features of the Hindu-Arabic numeration system. Okay, so let's continue. And we're going to look at some more definitions. We're going to look at different ways to represent numbers. We're going to look at standard form, which is just a good old-fashioned number, is a standard form. We're going to write and spell out numbers in the word form. We're going to place these digits in a place value chart. We're going to do expanded form, which we just did, the 2 forms. We're going to look at expanded notation, which uses exponents. And then we're going to introduce quickly base 10 blocks. So let's look at that. So the title of this section would be different ways to represent numbers. And we'll look at an example. Okay, so write the number 1,456 in expanded form. So 1,456. When I write this numeral, this is called standard form. If I were to write it out, that would be the word form. Let's go ahead and practice that. 1, remember the comma is your thousand. 1,450. Make sure you put a hyphen because it's 56. That is considered my word form. Okay. Now let's look at expanded form. In expanded form, we have 1,456. We can use a place value chart if you want to just draw a quick sketch so you'll remember. It'll be in your notes. 1, 4, 5, 6. Remember, this is my ones, my tens, my hundreds, my thousands. So we have 1,000, 4 hundreds, 5 tens, and 6 ones. So my expanded form is going to be 1,000 plus 400 plus 50 plus 6. We continue. That's 1 times 1,000. We have 4 times 100 plus 5 times 10 plus 6 times 1. So let me go ahead and stop and highlight here. This is called expanded form. We said this one was standard form. We did word form. And this is expanded form. And remember, there were 2 types of expanded form. One that has the addition symbol and one that has a multiplication in parentheses with plus signs in between. 1 times 1,000 plus 4 times 100 plus 5 times 10 plus 6 times 1. Okay, so let's look at expanded notation. Now this one is different. This is expanded notation. This is called expanded form. This one is expanded notation. Okay, the difference is that we have our exponents. So now when I look at my place value chart over here, and I wrote 1, 4, 5, 6 in my place value chart, I go up and I notice that the 1 is to the 3rd power. The 4 is 10 to the 2nd power. The 5 is to the 1st power. So let's put that in our notes. So we can put it, see if I have a different color here. This would be a 1, 10 to the 1st power, 10 to the 2nd power, 10 to the 3rd power. Or we could copy it over, I guess. 10 to the 3rd power, 10 to the 2nd power, 10 to the 1st power. And notice that I am using a 1. I am not putting to the 0 power. Okay, so let's go ahead and put it together. So this is going to be 1 times 10 to the 2nd power, 3rd power, 3rd power, plus 4 times 10 to the 2nd power, plus 5 times 10 to the 1st power, plus 6 times 1. Now, if I were in pre-algebra or high school, then I would probably write it as 6 times 10 to the 0 power. So here we have 1,456, which is standard form. We can spell it out in words, which would be my word form. We can set up a place value chart, which is this one right here, a place value chart. I put the digits in the correct place. We said there were 2 forms of expanded form, one with a plus sign, one that has a multiplication and a plus sign, and then expanded notation, which is our exponents. Okay, so let's write down the rules right here for reading and writing numerals. So it's important to note that the numbers 21 through 99 must be spelled out. So let's write that as a note. The numerals, or the names for the numbers, here we go. The names for the numbers 21 through 99, except of course 30, 40, 50, and so on, are hyphenated. Example, 47. Hyphen 40/30. 47. 47. Now I'm going to suggest that you practice reading and writing some numbers. Check your spelling, because spelling is very important to us as future teachers. Check to see. Notice how the number 40 is spelled. The number 15, 13, and so on. So be careful with your spelling. One example, 56,000. I just wanted to include one more example here. So the 56 would have a hyphen, 50, hyphen, and then 6. Notice the comma is my thousands. 56,000. Okay. So here's another example. 2, 015, 325. So we have the different periods. We have the ones period. Then we go over to the thousands period. And the 2 is in my millions period. Every 3 numbers, there's a comma. Every 3 numbers, there's a comma. And this group of 3 numbers is called a period. Okay. Now remember, the comma really does help me to read my numbers. So this is 2 million. Million is my comma. Then next comes, I have a 15. So it'd be 15,000. Then we have 325. So it's 2,015,325. $15,300. Now the 25 must have a hyphen. Remember, points will be deducted if you don't include the hyphen and if you misspell a word. So be very careful there. 2 million, because I should put my comma here. 2,015,325. Okay. As we continue reading numerals, be careful here. So let's write down this example. This is 705. Do not use the word and. Everybody does this. I do this by accident. I'll say 705. Or worse, I'll say 705. You ever hear people say that? There is no word and. And will come later when we do the decimal. The decimal point is my and. If I have 3 and 4/10. So the decimal is my and. We do not use it any other time. So this is 705 without the and. 32,005. 700,002. You kind of want to say that and in there, but don't. 700, the comma is your 1,000, 2. 700, let's write that one down. 700,002. So we have here 700. Then we have a comma. Then we have a 2. That's it. 700,002. We do not use the word and. Did I write that down anywhere? No, I didn't. Do not say and. Do not use the word and when reading and writing our whole numbers greater than 0. The and is reserved for decimals. Okay. So the last topic we're going to look at very briefly are base 10 blocks. In the next unit, we are going to be using base 10 blocks just like they do in elementary, to teach place value, to teach adding and subtracting, multiplying, and so on. Okay, so I'll do it on the next page here. So we have base 10 blocks. Let's just look at the names and their values. So we have a large flat, which is a 10 by 10 grid, and that is called my flat. Okay. Next, we have a rod, which is my 10 by 1. Sometimes people call it long, a rod or a long, but the more popular term is my rod. And then we have our unit, which is a 1 by 1. Okay. Now remember, the flat represents my hundreds, the rods represent my tens, and the unit represents my ones. So here I have a 17. Now when I decompose the 17, I'm looking at it as a 10 plus a 7. Well, the 10 will become my rod because it has 10 little squares in there. I'm not going to count them, I'm just drawing little lines. And then I'm going to have my 7 units. 1, 2, 3, 4, 5, 6, 7. So the rod represents 10, 11, 12, 13, 14, 15, 16, 17. Now we could also use a place value mat, which is a large sheet of paper or a file folder, and it just helps us to organize our pieces. So as we're grabbing our base 10 blocks, we're putting them in the correct region to represent ones, tens, and hundreds. So let's look at the number 364. Remember that is 300 plus 60 plus 4. It's got 3 hundreds. So I'm going to draw 3 flats because there's 3 hundreds. There are 6 tens. So I'm going to draw 6 rods. Now you can just draw a line if I'm kind of lazy sometimes. How many? 6? 1, 2, 3, 4, 5, 6. So we could just draw a line there to represent our rods. And then the ones, I'm going to put 4 ones. In some of the videos I've seen, instead of having to draw the little squares, you could. I've seen some of them where they'll put little X's. And it's a lot faster, or you can just draw your little squares. So I have 3 flats. Let's write that down. 3 flats. We had 6 rods, and we had 4 units. So these are the base 10, the pieces. We'll be actually creating some of these in our next lesson, and we'll be using them to represent numbers, and then of course add, subtract, multiply, and divide. Okay. So to finish up, let's go ahead and quickly write the number 347 using the following formats. So it'll be in our notes. Okay. So we have standard. A standard form is 3, 4, 7. Uses the digits 3, 4, and 7. In word form, we have 340 with an O, 7. Make sure you put a hyphen in between. 347. Now we can get those digits and place them in a place value chart. So here's my place value chart. This is my ones, my tens, my hundreds. Okay. We can do expanded form, the 2 versions. So it's 300 I don't need parentheses. 300 plus 40 plus 7, or 3 hundredths, 4 tenths, plus 7 ones. There we go. This is called expanded form. In expanded notation, we write our exponents. Okay, I'll just do a separate little chart here since I ran out of room over there. Remember, we start with a 1, then we go to 10 to the first power, and then we go to 10 to the second power. Okay, so expanded notation uses exponents. So that is going to be 3 times 10 to the second power plus 4 times 10 to the first power plus 7 times 1. And again, in some textbooks, they'll put 10 to the 0 power here, and that's okay. Let's go ahead and draw a sketch of our base 10 blocks. Okay, I'm going to go ahead and place it in a mat to represent or to simulate my place value chart. I'm going to put my 3 flats, 1, 2, 3, 4 rods, and my 7 units. Base 10 blocks. So we have done the number 347 in the following formats. So we have standard form, which is 347. In word form, 300, and we spelled out the 40 with the O. We put a hyphen, so 40-7. We placed the digits in a place value chart. So I just did a quick little sketch here. We did expanded form. There were 2 kinds, 2 types of expanded form. 300 plus 40 plus 7. And the second one is 3 times 100 plus 4 times 10 plus 7 times 1. We also did expanded notation, which is our exponents, which is 3 times 10 to the second power plus 4 times 10 to the first power plus 7 times 1. We did a quick sketch using base 10 blocks in which we said we had 3 flats, 4 rods, and 7 units. And we just did a quick sketch of that. And we did our exponents and our base 10 blocks. Okay, so make sure that you have practice in writing numbers using the different formats up to including 4 digits. Okay, so this completes this unit. Don't forget, in the next activity, we're going to create a place value chart. And what I'm going to do now that I have my notes, I'm going to choose any one of these pages to glue my place value chart. I creased it where it says decimal. I folded it, and I'm just going to put some glue and glue it down the gutter of the center of my notebook. Okay, bye.